Good morning, everybody. It's the next day. I can't believe it. This is actually the best part. It's like a little stressful. Like, am I going to do it? I'm going to make it to the TV show or not? Or, am I going to do the work? But it's like, yeah, it made it. I don't know. There's something really nice about like creating a slide and then instantly sharing it, because it's not that much fun to make a slide. Like, nobody's going to see it. I don't even know if I'll lose it or not. Okay. So it's like last night I was like tossing and turning. I was like, I kept looking, all these views, subscribers. I was like, wow, this is going great. So, yeah, and I was like, oh, am I gonna get up today and do it? So like, yes, okay, it's Friday. Thankfully, it's Friday. I'm in the weekend. I told you I'm working on other stuff. So I'm not gonna film on the weekend. But this has been really fun. It's been really helpful and fun. And my little cat Evie, yesterday morning, she's so sweet because she knew about my Heather, she was right there. She knew about my New Year's resolution. So yesterday morning, I know I'm making this up. Yesterday morning, little Evie comes up to me and she goes, "Mom," just tries to not scratch me. Just so this morning she might have tried to wake me up, but she was down here already, ready to go. She's sitting up here. She's ready to go in the morning. So anyway, so I'll just talk about the slides that I made today. So today I'm talking about Mitchell rank. For last time we talked about measurable cardinals, now I'm talking about Mitchell rank. So I can't look at the slides while I'm talking here, so I just sent it to myself and I'm looking at the phone. Yesterday I was looking at my notes while doing it, so I have all my notes. I have my pre-slides notebook. Okay. I would also like to say that I suppose this Mitchell ranking, this is my thesis. I suppose the Mitchell ranking is non-standard because when I was looking at Cantor's Attic and I was looking at YEC, both of them say that if you're measurable, then you have Mitchell rank 0, which doesn't really go with the other degrees of large cardinals. In my thesis, you have Mitchell rank 1. So let me put up the slide now, so I'll let myself know, so we can go ahead and put the first slide up. So in some literature, it says that Mitchell rank 0 means you're measurable. And so I would say Mitchell rank, and in my thesis, it's Mitchell rank 1 means you're measurable. If you're at least rank 1, that means you're measurable. I think it's weird to say Mitchell rank 0 to mean measurable. So, yeah, and it doesn't go with the other degrees. 1, never mind. I'm thinking 1 inaccessible means you're a limit of inaccessible. So I guess it's okay. Maybe that does kind of go. Okay, so this is the way I'm doing it here. Let me know if you have some opinion on that. Okay, so the first slide is we're doing degrees of measurable cardinals. So this guy is saying, I'm not just a measurable cardinal. I'm a rank 2 measurable cardinal. And I don't know if you noticed, but if you look at his shoulder, he's got these little ranks, rank 2. And it kind of reminds me of in It's a Wonderful Life. Doesn't the angel have he's like a rank something angel, rank 2. That's what this is, like a rank 2 angel. He says, I'm a rank 2 measurable cardinal. Okay, now I'm starting to think, okay, could go the other way. I like it this way. I'm gonna leave it this way. Okay, so this is Mitchell rank 2. So what does that mean? So it means that he's not only measurable, but in M he's also measurable, and that's where it stops. Mitchell rank at least 2 means in M he's also measurable. Okay, so let's go to the next slide. So this is Mitchell rank 2. Let me see if I can. So an uncountable cardinal kappa has Mitchell rank at least 1 if it's measurable. Mitchell rank 2, I'm going to say exactly 2, but if it's measurable and in M, so it's measurable as witnessed by this J from V to M, and in M it's also measurable. But now if you look at these pictures of these guys, you can see that the first one has a rank 2, so he's got the two stripes. And then the next guy in M, and this is ranging over all the ultra power embeddings with critical point kappa. In M, it has their kappa is measurable, but it only is rank 1. And so that's showing that exactly rank 2. So this guy says, I'm measurable in V, and the other guy says, me too, I'm also measurable in M. Okay. And then there's lots of ways of thinking about it, and if you want to think about it as Mitchell order, Mitchell rank comes from Mitchell order, and also it's helpful to think of it as concentrating on measurable cardinals. So for the next slide, the Mitchell order is a ranking on the measures on kappa. So if kappa is measurable and like there's this kappa complete ultrafilter on kappa, we could say like there's a kappa complete ultrafilter mu. We say mu is the measure on kappa. Mu is a measure on kappa. So if you take kappa and you look at all the measures, and they are normal measures, but we can talk about normal later. If you look at all the measures on kappa and you rank them, one is inside the other. So nu is like, let's say another measure on kappa. Nu is Mitchell order less than. Nu is Mitchell order less than. Nu, I'm sorry, guys. Nu is Mitchell order less than mu if nu is in the ultra power by mu. Okay. So there's a ranking of the measures on kappa, this little triangle, it's the Mitchell order. So the order of a measure on kappa is the supremum of all the orders that are less than it plus one. And so the order of kappa is the supremum of all the rankings of the measures on kappa. Okay. And so another thing you can think of is that order of kappa is greater than or equal to 2 if there exists a mu, j from v to mu, j from v to m sub mu, and kappa is measurable in m sub mu. So kappa is less than j of kappa, and kappa is measurable in m sub mu. So m thinks that kappa is in j of the set of deltas less than kappa such that delta is measurable. Which means now we talked about last time that if kappa is in j of some set, then that set is a big set according to mu. So it's one way to say that is we say that order of kappa is greater than or equal to 2 if there exists a measure on kappa which concentrates on measurable cardinals. And so it would be rank 3, at least rank 3 if there's a measure on kappa that concentrates on rank 2. So that's another nice way to say it. Okay, so just to summarize, and yeah, I maybe want another picture here. Also, I'm still not sure if I'm just going to keep these slides or if I sometimes worry if I create something and along the way it gets worse and worse and it doesn't get if it seems to be the quality going down, I don't know. So I hope these slides are okay. It's not going to be that big of a deal if I have to go and make it like Beamer slides, but I kind of like the way these look. Okay. So we say degrees of measurable cardinals. We can say order of kappa is 1 if kappa is measurable. But it's not measurable in any m ranging over all the j's from v to m where kappa is the critical point. It's not measurable in any of those m. So that would be order kappa of 1. Okay. If you strongly disagree with me and you have a good reason, please let me know. Okay, order of kappa is 2 if there's a measure mu on kappa which concentrates on measurable cardinals. But there's no measure. I'm trying to say what does it mean to be exactly a certain level. But there's no measure which on kappa which concentrates on rank 2 measurable cardinals. And then in general, order of kappa is alpha plus 1 if you look at all the elementary embeddings with critical point kappa, there is one where the order of kappa in m is alpha, but there's no place where the order of kappa in m is alpha plus 1. Then it would be exactly alpha plus 1, the order of kappa. And the order of kappa is greater than or equal to alpha, where alpha is a limit if for every beta less than alpha, there's a measure which concentrates on measurable cardinals of order beta. Okay, so that's that. There's a lot of ways to say it. Okay, now I would say next time, I gotta hurry. Next time we're not gonna just jump right into degrees of supercompact. That's gonna be coming later. It's quite hard. The next really hard thing maybe next week we need to focus on is the proof that you can softly kill these things. And again, I want to make you want to look at like the schematic of like this diagram. It really feels like an action movie when you're in it because you're preserving and you're destroying at the same time. And you look at you survey and you say, what did I kill? Did I kill too much? Is it still there? So it's very fun. So next week we'll probably focus on that, but that might be too hard still. So we might have to do some kind of tedious things or some kind of easier type fun things. Okay, I'm trying to get out of here 5 to 10 minutes. So thank you everybody for hanging out. I hope you have a great day. I hope you have a great weekend. And thanks for watching. Thanks for hanging out with me. Have the best day ever. I'll see you soon.